So we're going to see what kind of trouble I can get myself in here. The main thing with design for manufacturer at this stage is that you listen to the terminology, then how I look at the process, which is not necessarily how everybody looks at the process. But there are key takeaways that I don't want to destroy this model, but this is where the configurations come in. And so thinking through the process, this part's good. This part's okay. Um, I'm looking at the geometry, thinking that we would be better off with maybe a D shape, or even leaving it with the reamed hole and putting a tapped hole in the end. We get rid of the bearing and go to that sleeve bushing. We get rid of the splines and go to even if it's a coupler, a shaft coupler with a set screw or something as a drive element. Even putting a flat on it is certainly more cost effective than dealing with the splines. So there's I'm going to say a few issues that we can resolve fairly quickly, and one of the processes in presenting an alternative would be to set up the configuration. So this we did out of the group, and so from the top level, I'm going to modify the revolve. So this is going to be well, I would want to name it a little bit better, because at some point, if this is adopted under the properties, I would probably want it to be the post modified or post Rev 2 or something that we would pick up. So maybe I'll go ahead and start that post revision 2. Okay, and then we go into the front plane, open up the sketch. I'm going to do something like the corner rectangle just to pick up those extents. I'm going to do a cut extrude and flip the side to cut, because that will put the arrow to remove everything outside of the rectangle through all both, and that makes those go away. All right, so now that I've done that, I did not pay attention to which side was which. So that's the 1/4 inch side. We'll go in, and I slipped into speed mode. I hit the S key, so let's go to the whole wizard on the command manager. And we're going to do a 1/4 20. And the depth 650, 500. Said if I am going to drill a hole another 100 thousandths is not that big of a deal to be able to have that extend on the tap. All right, we'll go ahead and accept. And then on this end, the whole wizard, we'll go back to the 3/8, and I wonder if that did catch the 28. We'll have to make sure that I didn't mess something up there. So 3/4 inch and 1 inch, and the position. I'll go ahead and accept. So now I got 1/4 20 and 3/8. And so what that's going to allow me to do is put a set screw in. Depending on the length of the set screw and how much engagement, we would be able to run in there. The other side, I was thinking on the link, so let's go ahead and close that. And nothing changes on this this assembly. We're just going to go through and we're going to open up parts and make some very basic changes. So if I do a link Rev 2, so the other option would be to save each of these parts and then build a completely new assembly, but I would also like to take advantage of not being able to quickly trade these out in my what if scenario. So I'm going to suppress the 1/4 20, whichever side I don't remember or didn't pay attention, doesn't necessarily matter. I'm going to switch over to a countersink. So the countersink in this case, like I said, because this isn't free rotating or isn't necessarily rotating on that shaft or on that screw, there's a possibility that if we hang on tight, we will thread at least one of these. So with a flathead, there's more surface, probably less chance that it will unwind, but yeah, probably not. So up to next. So it's still a question mark. What would we want to do with it? All right, my cut extrude then. We would go to suppress it as well. I'm going to open up the sketch. We'll drop in another 3/4. All right, so rather than trying to modify the existing, and let's go 750, we'll put the tolerance on it. Again, in the drawing, I don't know that I did that effectively, so through all or up to next. All right, from the right plane, tangent 2. So this gets a little strange with the hole wizard putting it on a cylinder. So with those two selections, I can go into reference geometry and create a plane. And I'm still going to say that this is easier than dealing with the 3D sketch. So the right plane brings it out tangent. So basically parallel and tangent to this cylindrical surface, this arc. And when I place the hole wizard item, an 832 can be kind of tight there, so at the very least, and back to how much torque we're actually going to be able to generate. And on a failure analysis, what do I really want to fail? The set screw gets a little loose or a little warbled up and fails, or the shaft. There's several considerations there of how we're going to manage these parts. All right, so we'll hide. All right, so that becomes 1. All right, and then the shaft is probably going to have the most in the way of changes. So I'm still happy with the well, the keyway. No, I guess not. So let's go ahead and create our next configuration. Shaft rev 2. And we'll suppress the keyway now. Let's see, are my pop-ups? No, I'm not seeing those. So let's put on the dynamic reference since those haven't been showing up. Then the dynamic reference in purple is showing me what the child features are, and the pointing up in blue are showing me what the parent feature is. So if I suppress those, I expect that both of those will be suppressed. So on the right plane, I can open up a sketch and we'll put in a flat. And actually, I don't want to pick up the tangency there again, so I'm better off just drawing the line. Select, control, select coincidence. Select, control, select coincidence. Because it is horizontal, I shouldn't need a midpoint, but I would like the flat, let's see, a 632. If we go look at our thread chart, is about 140, so if I made this 150, there's not a lot of flat there. In fact, we could probably get away without it, but the flat as a contact surface is still going to be better than just jamming the set screw into the cylinder, into the part. So 0.25 on our thickness. And since we're setting this up now, it doesn't like something there. So blind in condition, nope, nope. Okay, if it doesn't want to do that, then we will convert our edge in. And when I tell it to cut, I will extrude cut, pick the contour, and not a through all, blind in condition, 0.25. All right, and we're really expecting that it will shift it will be centered, but it would also, if there is a shift, it would give it enough to contact. Probably would not want the 1/4 inch to go much past, so might even loosen that up a little bit, but maybe not. All right, so the chamfer can stay there as well. On that shaft, we would probably be looking at a 1032 or a 1/4 inch. So if I were to do the same thing, coincident, coincident, and the length then, I'll make it 0.25. And it did not go horizontal on me that time, so horizontal. We'll go ahead and convert the entities, so picking that edge. Features extrude. Let's see, I'm not entirely sure which way I would want the pulley to be facing, the pulley housing, but we'll probably give this a good 1/2 inch just to make sure there's a contact surface there. All right, so as opposed to putting splines in, which I think are going to be fairly expensive, even the key slot as opposed to just taking a mill and blasting a flat, I mean, those are fairly straightforward. All right, again, I go back to the assembly and nothing has changed. The support then, we're going to go back and double check. I think I left one of these open with the oil embedded, and we're going to go down to the 3/4 inch. And when we find the 3/4 inch shaft, then the length, the housing ID 7/8, so 875 by 1 inch. Probably stay with the 1 inch. So a general rule would be 1-to-1. If I did not have enough room or I wanted to put in, say, the 1/2 inch bearing, I would probably put one on each side, depending on how much side load or how much support is happening on the other end. Since I don't know what those components are or what this is turning, then 1 to 2 times the diameter for the length of the bushing is probably a good way to go. So we want to download that one, and I'm going to pull my downloads and cut, and we'll go back into the project folder and paste. And when I get back to the SolidWorks side, we're going to take and suppress. So that went all the way down to the cut extrude, that's fine. That one should be okay. That one will suppress, and it also suppressed cut extrude 3, which I should be able to reorder. So that was kind of an afterthought. If I left click, as long as I don't drag it above the parent feature, it will let me reorder, and then that makes a little more sense on the direction. So a couple ways that we can manage this. If this stays at the 0.7, I did not make the configuration yet. All right, so when I catch up to the configuration, this is going to be the support R2. I really need to unsuppress, well, from the default, I need to unsuppress those. And be careful with the suppression states because I can get myself pretty messed up here. All right, so the choice is, do I want to drive this dimension as a suppression, or do I go ahead or out of the configuration of the feature, or do I go ahead and suppress that one and put a new one in? It's kind of a toss-up, but since we haven't done that yet, let's go ahead and configure the sketch. And so if I right-click on the sketch and configure the feature, and the properties text file is not available, so we'll have to see where that one landed. And if I double click on the sketch, I'm going to be able to kind of move this around a little bit until I can see D2. And so for D2, this goes to 875, where it will stay 0.75 into. So I don't have to create a new feature, but I can control its physical dimension or its suppression state from this configuration. So 0.875. It's going to have the same type of tolerance considerations of when I go to press this in, I don't want to compress it too much. Let's see, so that was going to be by 1 inch. We're going to ream this all the way through, so that part of it is not a big deal. ID tolerance is 0 to positive 1,000ths. The OD tolerance 877 to 0 to 1,000, so 878, so 2 to 3,000. So that's a fairly hard press. So if I ream this through at 875 in steel and then press this in, there's a good possibility that I'm going to have to go back with a 3/4 inch reamer just to make sure that I dust this inside surface so that my spine shaft is not going crazy. And then the other thing with the bushing is I might want to leave it just a little bit proud, sticking out the 10 or 15, maybe 20 thousandths. So again, we're not banging knuckles, pinch pointing, those several things that can happen here. All right, the last part of the assembly. All right, modifying this out, making these changes. We're going to do the crank assembly, R2, and accept it. And we know that the key is going to be a suppression. The bearing is going to be a suppression. And again, I'm making sure that if I highlight over the top, it shows me that I'm in R2. I can highlight and pick the post. And of course, it's going to freak out on the link. The link then is also going to freak out because when I change it to R2, and then the shaft will probably freak out as well. But I'm not worried about, I mean, it looks a little weird to see all of my R2s come up. So in this case, let's go ahead and fly these out, and I will hide the items that I'm not overly concerned with. I might as well go ahead and do one more R2. So this, oh, I forgot to check. It was for this configuration. So the catch-all is, if I go back to the default, is everything still happy? Whew. Okay, I didn't totally mess up there. So I go back into the crank assembly. We know that we have those errors. And if I build from the support out, I can hide these items. And we'll go back to the Windows Explorer and I'll drag the bushing in. And this should automatically be unsuppressed, but occasionally it won't. Oh, and I forgot to lock the rotations, so select a control select distance. Said I wanted to leave that like 0.5 millimeter or 20 thousandths proud. And under the mates, the concentric, we will, no, I'm not seeing it. All right, since it's not there, oh, and it's not there, interesting. Well, we'll see if it rotates. It kind of acts like it rotates, so I wonder why that one's not there. Okay, well, it's not going to hurt anything too terribly bad, so let's go with showing the link. Now its mates and the issues with the mates, and everything pretty much went suppressed, so those should be all right with the shaft, the parallel. All right, so concentric and suppress. And that one can suppress. We'll just go down the list because I'm probably going to want to have new mates to all of these anyway. So suppress. All right, so that got rid of one. But there are my geometries, and hey, I got the countersink headed in the right direction, so that was a good guess. All right, so let's show the post. And again, I would rather just go ahead and suppress those guys. The coincident to the ball should be okay. The concentric to the ball is going to be a problem. Those two faces are all right. Now, the height of the flathead might be a little bit of an issue, but we'll resolve that when we get to it. All right, and then show the ball. We'll line those guys up. The cylinders, concentric. I'm not worried about the rotation on that one. So let's see, that leaves the shaft. So somewhere, since we lost that pretty well, let's go back into the link and I will find plane 1 by expanding out that feature, and then those can be parallel. And then the shaft and the bore can be concentric. And if we rebuild that, and the shaft and the bushing. Now I'm not paying attention to, but I'm hoping that these are all getting applied to the current assembly. So let's say that contact. So just kind of like in the sketch, if I grab something and moving it, the way that it moves. No, I don't want to see, but that was interesting. Let's see if we can flip that mate alignment. And no, I don't want to see the components, but all right, if that's what you really wanted to do, we'll go that way. All right, so a little bit different. I think there are some design elements that maybe are a little more cost effective. If we come over to our library, then the other items that I would need to add are, let's go with the socketed cap screws and a countersunk. Now, for most cases, 3/8/16, in most cases, one of the reasons that we're going to the socket heads is we can get a little more torque than we can with a Phillips. It's less likely to strip. Just in a general assembly, disassembly, and I didn't pay attention. 375 on the length. So if I go to the top view and we switch over to the wireframe, I take it that's the 1/4 inch side. Oh, that's right, that was the 1/4 inch side. All right, so back into the link and we'll take advantage of the hole wizard being able to change that geometry fairly quick. Down to the 1/4 inch, hit OK. Save it. Worst case, if I cannot get back to the socket head editing the toolbox component, we would delete it and put it back in, but I think I can get to the 1/4 20, and the length we would want to be at least 1/2 inch. All right, so 1/2 inch is the overall from the flathead to the tip of the screw. Why don't we try one more time, see if it gives me another choice there. No. Then we will edit the toolbox component and go 0.75. All right, so that looks like it has pretty good engagement. If I hit the tab button, I can hide that guy. And then the last one finishing this up should be a socket set screw that typically we're going to see maybe a cup point. And the 3/8 I don't know why I wouldn't just go ahead and make both of those 1/4 20s, but let's stay with that for now. And we'll jump back into the solid and give that a distance, something like that. All right, we might want to adjust the depth, because again, if I go into the wireframe and look at the engagement, probably made that deeper, but if I adjusted the tap depth, I could probably get that pretty close to where the ball engagement and the tap depth are about right there. So if I was to put a pulley on this, if I was doing whatever on the drive, some type of compensating flex coupler, any of those, I maybe reduce the cost by being optimistic 10 or 15%. Right? It doesn't seem like a lot on one part, but again, are we making 10, 100, 1,000, 10,000, or this is all we're ever going to make? So all those considerations, all those little details are in the checklist, and it doesn't hurt to pose the question. And maybe even the other question is, do we need the post at all? Does we can take it to an infinite level, and at some point, this is what we're going to make, and this is how we're going to make it. Even to the point of the radius at the bottom, I don't know that we need that. I might be able to lessen that up for the relief and just put a chamfer in there. All of those become something that is cheaper to manufacture without going too crazy on the design. So we'll call this one good. One quick note, we'll save that, save all. And when I go back to this, nope, that wasn't it. Let's go to the recents and pick up our drawing. Notice that we got a couple of extra things in there, so that means that I need to check on the default because the socket heads and the oil embedded did not suppress. All right, so if I save that and we go back to the crank assembly, that should look normal again. And then if we wanted to make a duplicate, I would probably do a file save as, and we would give this the R2 designation. I would want this to be a completely separate file because again, I'm going to mess some things up. There's going to be missing dimensions. It's just a matter of and there is no exploded view in this one, so I'm going to lose that portion of it for now. But just to give you an idea, crank assembly 2, we go over and we change all of these to support 2, and these items all go through their process. I can do this fairly easy, but I am going to have to go through and make those adjustments and changes and remove dimensions and revisit the tolerances because something got lost there. And then those went away anyway, and that one should be all right. All right, so we go through and we make the updates and the adjustments here. Then we have another set of drawings that we can go through and send this out to manufacturer and say, quote me this one, quote me the other one, which one's going to be cheaper, and what affects to delivery, all that good stuff. So, all right, we'll call this this good here. I can beat it up some more, but I think I've covered most of the topics I wanted to include here.